Greetings, grade 12 learners and grade 12 teachers. My name is Tulani Mjikwa. I am a maths facilitator at the Maths and Science Infinity, which is also known as MSI. The MSI is working in collaboration with the Department of Education. Our purpose and aim is to make sure that the learners are improving results in both mathematics and physical sciences. Then today in this video, we will be looking at the revision strides. We are now going to look at the areas on which learners need to focus on, and also equipping teachers, advising teachers on how to do the revision for these learners. As you know that on the 8th of September 2023, the grade 12 mathematics will be sitting for their first paper for the trial examinations. Right. So, these last push strides are brought by the Eastern Cape Department of Education. All you need to do is to hold on to the learners that pass and push the 20%, those achieved between 20% to 35% learners, to a minimum of 45 marks. We know that any learner that got less than 30%, or that learner got less than 45 marks, that learner is considered as a learner who failed mathematics. So, teachers, let's make sure that we push these learners to achieve a minimum of 45 marks in each paper, paper 1 and paper 2. Right, if we to speak of paper 1, that learner achieves 45 out of 150, then that learner has achieved 30%. Then that learner passed mathematics. Then if you go again to paper 2, that learner achieved 45 marks out of 150. Then that learner passed mathematics. Then if you combine the two papers, 45 and 45, sum up to 90 marks out of 300, because each paper has got 150 marks. Then that learner has got a pass of the minimum of 30%. Right. This should be achievable by separating the amber learners and maybe your level 2s as well as in a separate class, and target certain minimum marks in each topic to revise. So it's very important, teachers, now at this point in time to know and understand the kind of learners that you are dealing with in such a way that you separate your learners. Or maybe in your school, there are 2 teachers teaching grade 12. So you need now to understand the strengths and the performance of your learners. Then therefore you divide such learners into different groups. Then in each group, you know which areas you need to be looking at, so that those learners can easily move up to a minimum of 30%. And we urge teachers, don't revise everything for these learners who are unable to achieve the minimum percentage, which is 30%. All right, now in this video called Teachers and Learners, we will be looking at paper 1, the structure of paper 1. How is the first paper, mathematics paper, is structured? Now we have this table. Looking at this table, we have the content, topic, standard marks, which shows us the weight of each topic in that particular paper, which is the first paper. Then the lemon, target marks. Now, if you want your learners to pass, what is the targeted mark in that particular topic? Meaning that now we are looking at the level 2s upwards. Then the minimum target. Now we speak now to directly to the level 1 learners that we are pushing to achieve a minimum of 30%. Right, so we are looking at the minimum target. Right, the first topic is algebra, equations, and inequalities. What is the weight of that particular topic in this paper, which is paper 1? Then this paper weighs about 25 marks. It can be more by 3 marks or be less by 3 marks, but it ranges around that 25 marks. So, these learners, this group of learners that we are trying to push to a minimum of 30%, we say to them, out of that 25 marks in question 1, because those equations, that algebra equations and inequalities, are there in question 1 of the paper, the learners must target the minimum of 15 marks out of 25. So that question 1, when you revise with the learners, make sure that they do get the minimum of 15 marks out of 25. Right. Then we move on to patterns, sequences, and series. We said these are the number patterns. The number patterns weigh 25 marks. If they are more, they can be more by 3 marks. If less, it can be less by 3 marks. Right. That is why it says 25 plus or minus 3. For these learners that we are focusing on, 20% to 35%, we say to them, out of these 25 marks, please come out with at least, with a minimum of 6 marks out of 25. We don't say they must get 6 marks. They can even get more, but not less than 6 marks out of 25. Right? Then, functions and graphs. Usually, question 4 and question 5 in this paper 1, which weighs about 35 marks. In this question, learners need, this group of learners we are focusing on need to target a minimum of 9 marks. Differential calculus. Differential calculus is divided into differentiation, cubic function, and then we have now the optimization. We are looking at 3 categories under differential calculus. So in total, we say to these learners, to this group of learners, please make sure that in this question you don't get less than 9 marks. In this question, you don't get less than 9 marks. Then when we go through the structure of paper 1, we will then now understand. We will then understand which sections in that topic where a learner has to make sure that they score the marks. Finance, growth, and decay. Financial mathematics, which weighs about 15 marks in the paper. We say in this question, a learner, this group of learners, at least, not less than 3 marks. It can be writing a formula, putting a formula down, then you get a mark for that. Formula and substitution. Please, my dear learners, don't get less than 3 marks in this topic. The last one is probability. The probability is divided into 5 parts, which you have the mutually exclusive events and independent events, Venn diagrams, tree diagrams, contingency table, and then the last one will be the counting principle. Then adding all these minimum targeted marks, then that particular learner, if making sure that you get 15 marks Under algebra, equations and inequalities, then 6, 9, 9, 3, 3. Then that is 45 out of 150. Then that particular mark is considered as a pass in mathematics. So in paper 1, let's make sure that our learners are getting a minimum of 45 marks out of 150. Fine, that was paper 1. Let's look at question paper 2, the second paper in mathematics. Right. We have only 4 topics in paper 2. Our paper 2, the second paper in mathematics, consists of only 4 topics. Then the first topic is statistics, which is also known as the data handling. This topic in paper 2 weighs about 20 marks. Can be more by 3 marks, can also be less by 3 marks. That is why you see is 20 plus or minus 3 marks, right? Our group of learners are those learners from 20% to 35%. We need to make sure that these learners do not score less than 45 marks. These learners do not score less than 45 marks in paper 2. So this is our target as we targeted in paper 1. So how are we going to make sure that these learners are scoring these 45 marks out of 150? Let's look at the statistics. The statistics weighs about 20 marks, but these learners, we tell them that when you go to statistics, make sure that you note the questions that can give you a minimum of 10 marks out of 25. Remember that there are questions that will require you to use formula. After using a formula, then you substitute. The formulas are given at the end of the question paper. Then you substitute. By substituting, you get marks. And then it's very easy to work with statistics because most of the time, many things we just use the calculator. All the questions are based on the calculator. Most of the 90% we are using our calculators. So make sure that when you substitute correctly into the formula that you have picked up from the data sheet that is at the end of your paper. The second one is analytical geometry. Analytical geometry, which weighs about 40 marks. Remember, in that analytical geometry, there are 2 questions that are there in paper 2, in your second paper for mathematics. The other question on analytical geometry is based on the polygons that you have studied in the earlier grades, grade 10 and grade 11. Your kites, your quadrilaterals, your triangles, right? Then the second question on analytical geometry is based on the circle analytical geometry that you studied in grade 12. Now, if now analytical geometry weighs about 40 marks in paper 2, what is the minimum target? The minimum target here is 10 marks out of 40. So, how to make sure that learners do get this minimum of 10 marks? Make sure that you choose the correct formula. After choosing the correct formula, make sure that you use the correct substitution. You substitute correctly into the correct formula that you have chosen from the data sheet that is at the end of your question paper. And always, don't use your brain. Just go straight to your calculator. Use your calculator. Even if it's 1 plus 1 and you forgot what is 1 plus 1, just press your calculator and say 1 plus 1, then the calculator gives you an answer. A calculator is always correct, only if your calculator is on degree mode. Right, then the other one, the third topic is trigonometry, which has got the biggest weight in paper 2 because it weighs 50 marks out of 150. So now, looking at trigonometry, which is 50 marks out of 150. What is the minimum target there? The minimum target here is 15 marks out of 50 marks. Remember, we are now dealing with the level 1 learners and a bit of level 2 from 20% to 35% because we want these learners to achieve a minimum of 30%. So once a learner achieves that 45 out of 150, then that learner is considered as a learner who passed mathematics. Remember, in the previous slide, I said for this group of learners that we are pushing to this minimum of level 2, which is 30%, we said, teachers, please do not revise everything with this group of learners. Or learners, please do not revise everything, but you need to revise those topics or those sections in which you will be able to get marks, these minimum targeted marks that will enable you to be able to achieve 45 marks out of 150. Then the last topic here is Euclidean geometry. Euclidean geometry weighs about 40 marks. We know it's really not easy to work with Euclidean geometry, especially for this group of learners that we are targeting. Then therefore, in that Euclidean geometry, please learners and teachers, we are urging you to make sure that the learners are getting a minimum of 10 marks out of 40 marks. Then therefore, if you say in the 3 topics, in 3 topics out of 4 topics, a learner has to obtain a minimum of 10 marks from each. Then in trigonometry, come up with 15 marks. If you add all those, they give you 45 marks out of 150. Then that gives you a minimum. That gives you a minimum of 30 marks. That gives you a minimum of 30 marks, 45 marks, which is 30% of 150. Then that particular learner will be considered as a learner who passed mathematics. All right. Now, I would like us then to look at the structure. I would like us to look at the structure of paper 1, which is the first paper. And learners, I would like to remind you that on the 8th of September, 2023, you will be writing 8th of September, you will be writing your mathematics paper 1. Right, let's look at the structure. In each and every maths paper, there is question 1. And in that question 1, we are looking at the algebra, equations, and inequalities. And this topic in question 1, in first paper, weighs about 25 marks. But we say to all learners, most especially this group of learners, which is between 20% and 35%, make sure that you do get a minimum of 15 marks, or you target 15 marks out of 25 marks. Right. There is always 1.1.1. That question 1.1.1 says solve. That question says solve for x. We start the question paper by solving for x. Right. That question, most of the time, consists a maximum of 3 marks. Right. Let's look now at how to deal with that question 1.1.1. We say, teachers, make sure that there are different ways in which the equation that will be in question 1.1.1 will be given. There are different ways in which that particular question can be expressed. Right. Now, we have A here. Here we have A. If you look at this, your equation has already been factorized. The only thing that now you have to do as a learner is to take each factor and you equate it to 0. And then from here is your 2x equals to 2. If 2 goes to the other side of the equal signs, then the sign of 2 changes. If you divide by 2 both sides, then your x will be 1. And then you come to the second factor, because the equation has already been factorized for you. Then now what to do here, you take 3 to the other side so that you will be left with x. Then the sign of 3 changes. Then you are now having x is equal to -3. Okay. Even the second one, if you go to B, you will notice that you are having how many factors here? You are having 2 factors. In this case, A and B is a case whereby your equation is given in such a way that the equation has already been factorized. What you do, you take each factor, you equate it to 0, then you solve for the variable, which is always x. So we said start by doing 5 or more examples of factor form equations only. When we say factor form equations, we mean now the equations in whereby the equation has been factorized. You are having factors. We say for A and B, take each factor and equate it to 0. Okay. Don't just do one example, teachers. Please, for your learners, collect about 5 or more examples of the same type of questions, making sure that these learners will be able to understand how to deal with such questions. After factor form, do 5 or more examples in standard form, preferably the expansions of the ones done above. Right. The ones above, the equation has been factorized. Now, coming to this one, let's remember, teachers, and remember, learners, that the equation that will be given in question 1.1 will always be a quadratic equation, unless we are doing a different curriculum. But if you are still doing the CAPS curriculum, the question 1.1 is always a quadratic equation. Right. Keep here in mind, making sure that the quadratic equation is equal to 0. This one is a key. This one is a key, that the quadratic equation is equal to 0. What does that mean? It means that whenever an equation is given, before we solve that particular equation, we need to make sure that that equation is in standard form. So copying formula correctly, do not opening brackets when substituting, and correct use of calculator. Okay. Do not rush to pass these steps, and no factorization at all. Okay. Right. Let's look at C. 2x squared plus 4x minus 6 is equal to 0. So if you are looking at this one, it's not yet factorized. But I can see something looking at each term. 2x squared, 4x, and minus 6. Always, learners, make sure that your equation is always equal to 0. Take everything to your left-hand side. Then on your right-hand side, you have your 0. Then consider the terms, the 3 terms that you are having. Not always you'll be having 3 terms, you can be having 2 terms. But consider the terms that you are having in your equation. When I look at the equation, I can see that I'm having 2 here. I'm having 2 in 4, and I'm having 2 in 6. So it tells me that it reminds me of grade A, of what I learned in grade 8, that when you are factorizing, you need to check if there is a common factor in the terms of the equation that you are dealing with. Now looking at this, I can see that 2 into 2 goes there once, 2 into 4 goes there twice, 2 into 6 goes there twice. So there are those equations that are not yet factorized, but there is a common factor in the terms of the quadratic equation. Then therefore, whenever there is a common factor, you need to take that common factor out. We have seen that in C, 2 is a common factor, so is 2 into x squared plus 2x minus 3. Then make sure that all this is equal to 0. Always on your right-hand side of the equation, your quadratic equation, you have your 0. Having that equal to 0 makes it a quadratic, makes it an equation. But without having that is equal to 0, then therefore it becomes an expression. So whenever we solve an equation, we don't solve an expression. Right. Let's now consider D. Look at D. You have 2x squared plus 6x. Consider now, is there any, because before you factorize, make sure that you start by checking in your terms if you do have what is so-called a common factor. Right. If now you are looking at 2x squared plus 6x, I can say there is 2 in 2 and there is 2 in 6. I can say there is x in x squared and there is x in x. So I can see that, okay, in these two terms have a common factor, which is 2x. And then I open my brackets, and then here I'm having x. And here I'm having 3. Then this becomes equals to 0. In that way, you can see now that this D goes back to B that we had above. And once you see that you're having terms in an equation that will give you a common factor, don't just, I'm talking to teachers now, don't just do one example, but make sure that you do multiple examples of the same kind. So as it is indicated here that do 5 or more examples. Don't say to learners, please take these and do them as a homework, but make sure that they are doing these examples right in the classroom. Right. 30. First, we said an equation can be given in terms of the factors. The equation has been factorized already. Number 2, the equation is not yet factorized, but looking at the terms, you find that there is a common factor. And whenever there is a common factor, take that common factor out. Number 3, now in this number 3, we have to focus on what we were told when we were young in grade 5, that when dealing with mathematics, we have 4 operations, which is multiplication, division, addition, and subtraction. For us to make the correct use of these operations, we follow what is known as BODMAS. Brackets, removing brackets, if they use of in the question, you must know that that of means multiply. D stands for division, M stands for multiplication, and A stands for addition. Then lastly, S for subtraction. This, every time in this BODMAS, you need to follow this order. If there are brackets, make sure that you first remove the brackets. If there is off, please deal with that multiplication. Division and multiplication. Then it's addition and subtraction. You always deal with equations using operations in that order of BODMAS. Now, E. 2x into x plus 2 minus 6. So what do we do then in this case? Now we can see there are terms and there are factors and there are brackets. What we need to do, let's consider our BODMAS. What does it say? The BODMAS says that we need to start by removing the brackets. Then that will become 2x squared plus 4x. Then we have minus 6, then this becomes equal to 0. Now, when solving an equation, whenever an equation is given, you need to factorize that equation. After factorizing the equation, you will be having your factors whereby each factor will be equated to 0. Then you get the required solution. Now, as you can see, it's 2x squared plus 4x minus 6. You can notice that there is 2 in 2, there is 2 in 4, and there is 2 in 6, meaning that in this equation we have what is so-called the common factor. Then now this becomes x squared plus 2x minus 3. It takes us back now to taking out a common factor. Even this one, number F, you need to start with brackets, remove those brackets. After removing brackets, you will check if there are like terms, then you add the like terms. If there are no like terms, but the equation at the end must be in standard form. Once an equation is in standard form, you then now refactorize the equation. Then therefore you will be having two factors, whereby now they will enable you to be able to get the required solutions. Solve for x. Fourthly, there are cases whereby x, you will find that one of the x's is in the denominator. There are fractions involved. Now, teachers make sure that you avail such questions to learners, and learners must be able to revise such questions. But that whenever there is a fraction, we need to deal with the fractions. X must not be in the denominator. Before we get our solutions or we factorize, let's make sure that our quadratic equation is in standard form. In each kind of a question, make sure, teachers, that learners are doing 5 or more examples. Number 5. Equations that require transposition and grouping and addition of like terms. We said an equation, the quadratic equation, will be standard only if it is equated to 0. Now, if you have terms on the left-hand side of the quadratic equation and terms on the right-hand side of the quadratic equation, you need to check if there are any like terms. Then if you have the like terms, then you add the like terms. If you don't, make sure that all the terms are moved to one side, which is the left-hand side. After moving all terms to the same side, which is the left-hand side, check if you do, before you factorize, check if you do have a common factor. Check if your terms have a common factor. Okay. For an example, this one, which is I, is 2. Where's my pen now? Looking at I, this becomes 2x squared. Taking negative 4 to that side will be plus 4x. Then minus 6 equals to 0. Now, my equation is in standard form. Before we factorize, let's check if there is any common factor. Now, by looking at it, I can see that I saw something like this before. 2 into 2 goes there once. 2 into 4 goes there twice. 2 into 6 goes there twice, 3 times. So I will be left with x squared. What are you doing now? X squared plus 2x minus 3 equals to 0. One thing you did, you made sure that the equation is in standard form. Number 2, you checked if you have a common factor. Number 3, and then now in this case, you then factorize. Then you're having your x, then it's plus and minus, always plus, goes to, becomes the sign of a bigger number. So, what are the factors of 3 that will give, that will sum up to positive 2? And then here you will be having minus 1. Then your solutions will be x equals to negative 3 or x is equal to 1. An equation must be in standard form. And check if you have a common factor. Then after taking out a common factor, if it is there, you then refactorize your equation. Then you will get your solutions. 5. Number 6, they are mixed equations. So the very important thing that you need to do in this kind of equations, J, K, and J and K, make sure that the equation is in standard form. And in order for you to deal with this kind of equation, make sure that you understand your body mass. You need to use your body mass. One point 1.2. Still, question 1. These are the equations whereby a learner is not required to factorize. But in order for a learner to get the solutions, you just need to put the equation in standard form. When the equation is then in standard form, what you need to do, you just need to use the quadratic formula, which is at the back, which is in the data sheet at the end of your question paper. Okay. Then 1.1.3, these are the inequalities. So the difference between the equation and an inequality is that an equation has got equal signs. An inequality has got the signs greater than, less than, or greater or equal to, or less or equal to. So whenever you see greater than or less than, greater than or equal to, or less than or equal, you must know that is not an equation, but it is an inequality. So solving an inequality, you just use the same approach that you used when you dealt with the equation. The only change here are the signs. Simultaneous equations. Now we have key principles that we need to know and understand. Bullet number 1, making the subject of the formula in literal equations. Make sure always when solving quadratic equations, one of the equations will be quadratic and the other one will be linear. Now, we advise learners always look at the equation that is simpler or the simplest equation. And then when you take that equation, make sure that you let one of the variables be the subject of the formula. After making that, after doing that, or after making that one variable be the subject of the formula, you then take that and substitute into another equation. Then, in that other equation, you will then now be having only one variable. Then simplify or try now to work out that particular equation. We say simplification by distributive law, step by step, do not inspect. Make sure that now that particular equation that you are left with, which is quadratic, make sure that you put that equation in a standard form. Then you follow the rules of solving a quadratic equation. In the case whereby you cannot factorize, or it takes time for you to think about the factors of the equation, please don't waste your time. Go straight to the quadratic equation or quadratic formula, which is at the end of your question paper. Whenever you feel that this I cannot factorize, please try to use the quadratic equation. But we advise don't factorize, but go straight to your quadratic formula. Calculator. To use calculator to get the values. Don't crack your skull thinking about the final values or the final answers. Just after substituting into your quadratic formula, then use your calculator to determine or to calculate the values that are required. Find the corresponding values of the other variable. Remember, you had that equation that you started with, in which you substituted it into the other equation. Then you go, after getting the variables, the solutions of the other variable, you then now go and find the other corresponding values. If you started by getting values for y, then now you need to get the corresponding values or the corresponding x values to the y values. Right. 1.3. There are 1.3 questions. This can be done to increase the target from 15 to 30 to 20% in algebra. Key principle, seclude the set by transposing everything outside and the set to the other side. What does that mean? When we set equations, what is a set? When you see set, then we refer to whatever is expressed in terms of roots. It can be the square root, it can be the fourth root, it can be the any fifth root, sixth root, okay, or cube root. So whenever you see a root, you must know that is a set. A set. Then, when we say transpose everything outside the set to the other side, what does that mean? We mean that on one side of the equation, you must be left with something that is under the set, or you must be left with the square root. All the other things must go to the other side. After doing that, you then now square both sides. By squaring, if you're having a square root, then that square removes the square. Remove the square root. If now you're having the cube root, then you raise all that to 3. Then that cube root goes away if you let everything be having an exponent 3. Okay, now, why is it going back? Right. So squaring everything using brackets for all the left and on the right hand side. So we do that is to remove the root or the set. Simplification, squaring a square and distributive law step by step. Quadratic formula, always you use the quadratic formula. Don't try factorization to get the values. And don't crack your skull to find values. Always use your calculator. After getting your values, you need to take those values and test them into the equation that was initially given to you and check if those values are giving you the correct solutions. Okay, all these need to be demonstrated using different examples from different question papers. As you know, teachers, that you are urged to use different or several question papers when doing revision for learners. Also, you learners, whenever you revise, don't use only one or two question papers, but use different question papers so that you will be familiar into different kinds of questioning styles. Do not mix different methods as they will confuse these learners. Please, teachers, we know as teachers, there are so many methods that we have, but stick to one method which you think that that particular method will work effectively for your learners. Make everything routine. That was our question 1. Let's come to question 2. Sequences and series. Sequences and series. They weigh about 20 marks, but we target a minimum of 6 marks for the group of 20 to 35 marks because we want everyone to pass. So in order for everyone to pass, to say everyone has passed, let's make sure that everyone has achieved a minimum of 45 marks out of 150. Expanding the sequence. Key principles to be hammered that we need to emphasize, to be hammered. Use a hammer there. So we emphasize. Get as many examples as you deem fit. Writing the next 2 terms. So if it's an arithmetic sequence, or a geometric, or a quadratic sequence, or a mixed staggering sequence. But what we need now to know to do when we do revision with our learners, whenever a sequence is given, a learner must be able to identify what kind of a sequence it is. Is it arithmetic? Is it geometric? Or is it quadratic? And that 2 marks must be obtained by each and every learner. Every learner, after identifying the type of a sequence it is, then the learner must be able to get the next 2 terms. So that 2 marks has to be obtained by each and every learner. So when you go to sequences and series, as a learner, you must know there's my 2 marks there. That 2 marks always says, write down the next 2 terms. Right. General terms. The general terms now are the rules that we are enabling us to determine any term that is in the sequence. The value of any term that is in the sequence. Also, we use the general terms to determine the number of terms that we have in the sequence, or we determine the position of a particular term in a sequence. For an example, a question can say, determine the nth term for all kinds of sequences. you use the formula for each sequence. If it's arithmetic, you know there's Tn is equal to a plus n minus 1 all times d. Then there is a general formula for quadratic. There is a general formula for geometric. Determining that which term of the sequence is equal to a particular value. Now we are determining now the position of a term in the sequence when the value of that particular term is given, but now we want to get the position of that particular term. Okay. Determining a particular term in the sequence. In that case, you will be told which position is occupied by this particular term in the sequence. But now we want the value of that term. So determining, for an example, questions like determine T10, T5, T100. Now they give you the position of the term. Then you need to get the value of that particular term in the sequence. Series or sums. We have an arithmetic sequence, we have a geometric sequence, and we have a quadratic sequence. In these three, we need now to be able to determine the sum of a given number of terms in the sequence. But for quadratic sequence, you will not be required to determine the sum you will not be required to determine the sum of terms of the quadratic sequence. You will always be required to determine the sum for arithmetic sequence and for geometric sequence. And the formulas to do that are given at the end of the paper. At the end, the data sheet, which is at the end of your question paper, the formulas to determine the sums, expanding, and also learners, you must be able to deal with the sigma notations. Right. Looking at the geometric sequence, it is divided into divergent geometric sequence and the convergent geometric sequence. So a convergent geometric sequence has properties, or has got a property that enables us to identify if our common ratio is less than 1, but that common ratio is greater than 1 in the geometric sequence, then that particular geometric sequence is said to be convergent. So in such cases, you will be required to determine the sum to infinity. You will be required to determine the sum to infinity of the terms or the sum to infinity of the convergent geometric series. So those are the things that you need as a learner to understand, as well as teachers. Make sure that you hammer these principles. Topic number 3. Functions and graphs. Functions and graphs. In this topic, we are targeting a minimum of 9 marks. It can be 10 marks, but don't get less than 9 marks in this topic. 3.1. In each and every question under functions and graphs, learners make sure that you are able to determine the intercepts. What is an intercept? An intercept is a point on a graph whereby the graph crosses the x-axis or the y-axis. That point is said to be an intercept whereby the graph crosses one of the two main axes, x-axis or y-axis. Determining the x-intercept of any function, emphasize substituting y or f of x by 0. Whenever we are trying to get the x-intercept, learners, the first thing that you need to do, you let that y or you let that f of x or g of x or h of x or k of x you substitute that one by 0, and then you solve the equation using the principles of solving the quadratic equation. If it's a quadratic equation, but you're using the principles of algebra. Most of them we dealt with in question 1, when we dealt with the algebra equations and inequalities. X-intercept of any plotted graph based on the critical points given. You must be able to get y-intercepts, you must be getting the x-intercepts. Right, still working on the intercepts. Determining the intercept, the y-intercept, emphasizing substituting x is equal to 0. So in order for a learner to be able to get the value of the y-intercept, make sure that in the equation you put 0 in place of x because you want y. If you want an x-intercept, make sure in place of y you put 0 because you want x. Fine. The y-intercept of any plotted graph based on the critical points given. You may find that the graph has been given and you can easily see the y-intercept right from the graph which is given, because it is a point whereby y-intercept is a point whereby the graph crosses the y-axis, whereby the x-intercept is a point on the axis whereby the graph crosses. Okay. Turning points or equations of the asymptotes. Turning points, you need now to know we are having straight line, having hyperbola, exponential function, as well as the cubic functions. Turning points we do have in a quadratic equation. So you must be able to determine the coordinates of the turning points. If you are given a hyperbola or you are given the exponential function, you must be able to determine the values of the horizontal and the vertical asymptotes. Horizontal and vertical asymptotes. So also in a hyperbola, you will remember that a hyperbola has got two asymptotes, equations of asymptote. But looking at the exponential function, it has got only one asymptote. So for turning points of functions, under functions and graphs, only the parabola has got a turning point. Only one turning point in a parabola. The other term for parabola is quadratic function. Okay. Sketching domains and ranges. It's very important, teachers, to hammer these principles. Each learner has to know the range of a linear function, the range of a parabola, the range of a hyperbola, and the range of an exponential function, as well as the domain of each of the 4 functions. It's very important that 2 marks must be grabbed by the learners. Okay, then there are parameters. These can be optional depending on how they respond. So there are those questions which weigh about 5 marks or 4 marks at the end of the question. So please, learners, don't stress yourself about those questions, but make sure that 3.1, 3.2, and 3.3, you really understand those ones. And you grab marks as much as possible in making sure that you score 9 marks. A minimum of 9 marks in these functions and graphs. Right. That was the end of functions and graphs. Now we come with basic calculus. Basic calculus. In calculus, which is divided into 3, is differentiation, cubic function, then the last one will be optimization. But now let's look at the derivative. Derivative, now we look at the differentiation. When we look at the differentiation now, in each and every question paper, there will be a question that requires a learner to find the derivative from the first principles. That question can be most of the time, that question weighs about 5 marks. Sometimes it weighs about 4 marks, but usually has 5 marks. We emphasize copying the definition, which is the formula, correctly from the data sheet or the formula sheet, which is at the end of the question paper. After copying the formula as it is correctly, then learners must be able to substitute correctly into the correct formula for finding the derivative from first principles. Then you simplify using the laws of dealing with equations. They're not leaving h as tends to 0 until one step before the final answer. Please, teachers, emphasize that to the learners. Derivative using rules. Use SRFED. Simplify, radicals, fractions, then differentiate. You cannot derive an equation when it's not simplified. If there are radicals, by radicals we refer to square roots and cube roots. Then if you are having fractions, you cannot factorize an equation while there are fractions. We need to make sure that we get rid of the fractions, then the equation must be in a standard form before we differentiate. If we don't have radicals, we don't have fractions, and then the equation is simple in the standard form, then now you can differentiate. So, as the key to eradicate notational errors. So that was number 1, we're looking at the differentiation. Okay. Cubic function. This is part 2 of differential calculus. Intercepts and inflection. Learners must be able to determine the intercepts with the x-intercepts and the y-intercepts. It doesn't matter what kind of a graph it is. Whenever you want to determine the x-intercept in an equation, make sure that your y is substituted by 0. Then you solve for the x. You can use long division, you can use synthetic division, you can also use the K method or inspection. Intercept of any plotted graph based on the critical points given. Then you must be able to determine the point of inflection. The point of inflection refers to a point on the curve whereby a curve changes from being concave down to concave up. Y-intercept, you just do the opposite of what you did when you are determining the x-intercept. Right. Cubic function now has two turning points. Remember, we said a quadratic function, which is a parabola. A parabola has only one turning point, but a cubic function now has got two turning points. Parabola has one turning point, then cubic function has two turning points. Right, the turning points of functions, derivative equal to 0. Always now derive that cubic function. Find the derivative. After finding the derivative, you let that derivative be equal to 0, which is f prime of x, of h prime of x, g prime of x. You let them equal to 0, then you solve for the remaining variable, usually x. Then determine the corresponding y value after getting the x values. Then learners must be able to get these marks. Sometimes it has 2 marks. Sometimes it can be 2 marks or it can be 3 marks. Okay. So, equations of asymptotes of functions. No, I went back. Okay, I went back. Okay, turning points, I was there. Then you must be, after determining your x-intercepts, your point of inflection in a cubic function, your y-intercept, and your turning points, learners must be able to sketch the graph. Learners must be able to sketch the graph. Very important when sketching the graph, indicate your x-intercepts, indicate your y-intercept, indicate your turning points, then finally you indicate your point of inflection. So that 5 marks is for all these things that I have just mentioned. So most of the time, there are 5 marks that are allocated for that particular question, whereby they will say, sketch the graph of H or the graph of F. After sketching the graph, you must be able to determine the domain and the range of each graph. That particular cubic function you have drawn, you must know what its range is, and then there are asymptotes. There are vertical asymptotes in some cases in the cubic function. Okay. Right. 5.5, there are parameters, but we say to these learners, don't stress yourself with these last questions. Then number 6, applications of calculus. We say to this one, learners just target 3 marks. Questions which will say, find the maximum, the values of x that will maximize the profit or maximize the product, but always find the derivative be equal to 0, and then you solve. When dealing with the applications of calculus, just target a minimum of 3 marks. We understand in this question, learners have a challenge a big challenge when it comes to the applications of calculus. If it happens, just go there and grab your 3 marks and go. Right, that was the end of calculus. That was the end of calculus. Number 7, finance, growth, and decay. We call this the financial mathematics. We call this one the financial mathematics. Simple growth, decay, making different parameters is the subject of the formula. So we start now by simple interest in our revisions. Simple interest and simple depreciation. Simple compound interest, and which is compound growth and decay differentiation. So there must be difference between simple interest and compound interest, as well as compound depreciation, as well as the simple depreciation. Learners must be able to make use of the formulas. Learners must be able to choose the correct formula from the back or from the data sheet or formula sheet that is at the back of the question paper. Simple future value, dealing with the simple sinking funds in grade 12. This one is in term 3, grade 12, term 3, future value annuities, dealing with the sinking funds. So also learners must be able to read the statements, analyze the statement, and be able to differentiate between the formulas of future value annuity and that one of the present value annuity. So for present value annuity, we are dealing with loans whereby people are borrowing monies from banks, from people, or from any financial institution. So in this question, we say, learners, can you please try to be able to pick the correct formulas from the back of your question paper and then obtain at least 5 marks. The last topic in question paper 1 is probability and counting. You say here, just come out with the minimum of 3 marks. Minimum of 3 months. So teachers, whenever you are doing your revision with the learners, make sure that you revise the concept starting from grade 10, work with the dependent events and mutually exclusive events. Grade 10 as in grade 11 work. Formulating a diagram or tree diagram from a statement. Now, when you are dealing with these questions, mutually exclusive and dependent events, you need to give them about 10 or more different questions so that they are getting used to it and then they understand it. Venn diagrams, learners must be familiar with working with the Venn diagrams, to draw the Venn diagram or be able to analyze when the Venn diagram is given. Then for tree diagram, a statement will always be given, but then the learners need to read and analyze the given statement so that they will be able to draw the correct tree diagram. Solving simple contingency table. I think this is the simplest in grade 11. How to deal with those contingency tables. I would say to learners, just get all those marks from the contingency table because that one is the simple. But please, teachers, make sure that you give them so many examples from different question papers, previous question paper. Counting principles. Counting principle, which is now a new concept that is in grade 12. Simple combinations with repetition and no repetition. So, make sure, teachers, that the learners are given as many examples as possible from different question papers so that they are familiar with the counting principle. They are familiar with the terminology that is used in counting principle. This was the structure of the first paper, which is paper 1. This is the structure of the first paper. Now we are trying to make sure that you learners know how to do your revision. You know which concepts you need to focus on and how you are going to do your revision. So this is the end of our video for the strides on paper 1. Let's meet again in the next video whereby I will be giving you the strides on paper 2.